When a is positive, the graph opens upwards. When a is negative, the graph opens downwards. So we were already a little familiar with that. Now the new stuff. When a is greater than 1 or less than -1, so whole numbers, the graph is stretched vertically. And when a is in between -1 and +1, and it cannot equal 0, the graph is compressed vertically. When these three transformations are combined, the resulting equation is the standard form of the equation of a quadratic function. I already talked about that a little bit at the beginning of this lesson. This is standard form for quadratic equations. After all that, let's dive into an example and see what we find out. Example 1. Graph the function y equals x minus 1 all squared plus 2. Well, from what we just learned, we can figure out how this graph will look. Think about our original quadratic function of y equals x squared. Now, this is only asking us to remember the opposite for this, and it's going to go right 1 point. And it's going to move up 2 points from these changes in our quadratic equation. So, it should look like so. We're going to move right 1 and then up 2. So now our vertex is at the point 1, 2 is our vertex. Alright, and from there we just go ahead and finish our regular quadratic function. And we go over 1, up 1, over 2, up 4, and then over 3, up 9. Just about up here. And voila! There is our parabola. That's the graph of that function. Let's try another one. This one looks a little harder. Now we have the function y equals -3 onto x minus 4 all squared minus 2. So let's pick it apart again. This part means we're going down 2 units. This part means we're moving right 4 units. And then this part, the -3, means we're getting stretched, because it's a whole number, by a factor of 3. And we're flipping, because it's a -3. So let's find our vertex first from these 2 points here. Our vertex is down 2 and right 4. So here's our vertex now at the point 4, -2. So, and it's going to be opening downwards now because of the -3. So instead of moving up 1, we're going to move up 3. So over 1, up, because we're getting stretched, right? So it's going to get skinnier. And then instead of moving over 2, up 4, we're going to move over 2, up 12. Which is going to be somewhere way down here. So if we just kind of sketch this here, our graph would look something like this. That is being stretched by a factor of 3 in the downwards direction, with our vertex moved right 4 and down 2. Let's try one more example. The graph of the quadratic function is shown. Now what is the equation of the graph? So we want an equation, a onto x minus p squared plus q, of the form in standard form. So what can we tell by looking at our graph here? So let's start off with p, for example. Now our graph has moved to the left 2 units. So moving left means it's positive, and then it's 2 units, so we have 2. There's our first step. What about our Q? Now, it went downwards 3 units, so it is a -3 for our Q. And lastly, our A here, well, it opens downwards, so we know that it's a negative value. And it looks like it went over 1 up 2, so it's being stretched by 2 units. Hence, our equation for this function is y equals -2 onto x plus 2 all squared minus 3. Now, I just want to leave you with a quick note that our q in our equation here shifts up and down. Our P shifts left and right, and our A stretches or compresses the graph. So those are our rules for those variables.